నువ్వు అన్మ్యూట్ చేసుకొని హోస్ట్ చేయి. నువ్వు అన్మ్యూట్ చేసుకొని హోస్ట్ చేయి. Good morning, students. Good morning, all of you. Today we will start next chapter. Next chapter is monotonicity. Monotonicity. Look at what is meant by monotonicity is an increasing function or decreasing function. An increasing function or decreasing function is called monotonic function. The definition is simple definition. An increasing function, either increasing function or decreasing function. These both functions are called monotonic function. What is increasing function we will see. Suppose let us say y equal to f of x. Y equal to f of x. F of x, look at, if with increase of x, if with increase of x, if y value increases, if with increase of x, if y value increases, then f of x is called increasing function. Increasing function. Increasing function. That means if you increase the value of x, y value increases. Such type of function is called increasing function. Increasing function. Suppose let us take an example. Suppose example y equal to e power x. Suppose take an example. Y equal to e power x. Right? So suppose at x equal to 0, at x equal to 0, y value is what? 1. At x equal to 0, y value is 1. So at x equal to 1, if you increase x, y value is what? It will increase. So previously it is 1, now it is e, that means 2.772. Similarly, if you increase x, y value keeps on increasing. Y value keeps on increasing. That means if the increase in x, then y value also increases. Such type of function is called increasing function. Look at the definition of increasing function. Let let the domain of f of x, let the domain of f of x be D. Domain defined is D, let us see. Let the domain of f of x be D. F of x is said to be increasing function in domain D. In domain D, it is defined in the domain D. F of x is said to be increasing function in domain D if x1 less than x2. Found only if f of x1 less than or equals to f of x2 for all x belongs to S. Look at here. For all x1 comma x2 belongs to domain. Suppose in the domain there are two x values. x1 is one value, x2 is one value. x1 less than x2. That means x1 is less than x2. At x1, y value is what? F of x1. At x2, y value is what? F of x2. If you take x1 less than x2 and suppose y values are like this, f of x1 less than f of x2 are equal to x2. That means for this lesser x1, f of x1 is what? Lesser one. For this x2, f of x2. That means f of x1 is less than f of x2 means what? Y value keeps on increasing. Look at the graph. Look at suppose you observe the graph. Observe the graph. Suppose the graph is like this. The graph is like this. Right? So let us say domain is A to B. Domain is A to B. The function is defined from A to B. Domain, this D is A to B. Suppose you take two values in A to B, two values you take. Let us say this is x1, this is x2. Look at this is x equal to x1, this is x equal to x2. At x1, what is the y value? What is the y value? This is the one. F of x1, this is the y value. At x2, what is the y value? This is the y value, f of x2. That means at initially x equal to x1, this is the value. At x2, this is the value. That means if x increases, x has increased from x1 to x2, and f of x1 is increased from f of xy value is increased from f of x1 to f of x2. That means y value keeps on increasing. Suppose look at here. Here one value will be there. X. Here x value if you take, y value increases. Here x value if you take, y value increases. Here x value if you take, y value increases. Like that it keeps on increasing like this. That means y value keeps on increasing. That means from A to B, clearly if it goes on increasing like this, it is called increasing function. It is called increasing function. That means if you take in the domain two values x1 less than x2, if it satisfies the condition, if you apply f of x1 less than or equal to f of x2, f of x1 less than or equals to f of x2, that means the lesser value of x will have lesser value of y, the greater value of x will have greater value of y. So this is the graph where x1 less than x2 implies f of x1 less than f of x2. Let us say this is graph 1. Let us say this is graph 1. Let us say I am drawing another graph. Look, I am drawing another graph. Suppose if the graph is like this, look at. The graph is like this. The graph is like this. Suppose domain is A to B. Domain is A to B. A to B. A to B. So here, this part of the graph is parallel to x-axis. This is a straight line from here to here. A to B. Let us say C to D. C to D. In between A and B, C to D is there. In C to D, graph is parallel to x-axis. Right? Now look at, in A to B, you take two values of x, x1, x2. Suppose look at, I am taking here x1, here x2, here x2. Let us say. So for x1, where is the y value? F of x1 is here. For at x2, where is the y value? F of x2 is here. That means you got x1 less than x2 implies f of x1 less than f of x2. Right? Suppose if you take x1 here, x2 here. Suppose you have taken like this. That means what you will get? F of x1 equal to f of x2. If you take in this region x1, x2, f of x1 is this value and f of x2 is also same value because this is a line parallel to x-axis. That means in this region f of x1 equal to f of x2. So next, suppose if you take here x1 between D and B x2, so look at, here f of x1 will be there, here f of x2 will be there. That means this is f of x2 and this is f of x1. Again, x1 less than x2 implies f of x1 is this, f of x2 is this, f of x1 less than f of x2. Suppose like this graph will be there, like this, it has increased like this, then maintain the same value, parallel means same value will be there from here to here, and then it has increased. This type of function will satisfy x1 less than x2 if and only if f of x1 less than or equal to f of x2. Here, here always f of x1 less than f of x2 only. Here what happens is equal to f of x2 will also be there. From here to here, f of x1 equal to f of x2. In the remaining part of the graph, whenever you take x1 less than x2, f of x1 will be less than f of x2. Let us say this is 2. Both functions are called increasing functions. Look at, if x increases from a to b, y value has increased, increasing like this. Here also, if x increases from a to b, the graph is increasing like this, but from here to here same value is there. From here to here it increases, but never decreased this, but never y value decreased. Here also y value never decreased. These two types of functions are called increasing functions. Look at it. So in increasing, there are two types of functions. In increasing functions, are of two types. Number one, it has two different names. Number one, strictly increasing function. Strictly increasing function. Strictly increasing function means, look at this type of function. That means it will never maintain the same value also like this. Strictly increasing function means x1 less than x2 less than f of x2. Like this, strictly increasing function means there won't be any equal to. There won't be any equal to. Like this, number one, first graph. First graph. This. So this is also said to be increasing function only, but it has particular name. Strictly increasing function. That means first graph. What is the difference between this and this? From here to here, same value is there, but this graph is increasing from A to B. There won't be any same value also, always keeps on increasing. So such type of function is called strictly increasing function. Look at here. If x1 less than x2, this is the one. Suppose if here greater than is there, greater than is there, then here greater than will be there. If such type of x1 less than x2, if you apply f and it is strictly increasing function, then what happens is same inequality will maintain. Less than means less than, greater than means greater than, like this, strictly increasing function. Number two, non-decreasing function. Non-decreasing function. It is also called increasing function, but it has particular name. Non-decreasing function. That means it will never decrease. It will increase only, but will never decrease. Look at here. From here to here, it has increased. From here to here, same value. From here to here, again it has increased, but has never decreased. That's why it is called non-decreasing function. What is its definition? Is x1 less than x2 if and only if just equal to will also be there. Equal to will also be there. Equal to will also be there. F of x1 less than or equal to f of x2. So from here to here, if you take x1, x2, then they are equal. Anywhere, if you take f of x1 less than f of x2. Similarly, if greater than is there, greater than is there, greater than or equal to. This is 2, second graph. Second graph. When x1 less than x2, if you apply f, then same inequality will maintain, but of course less than or equal to. Greater than, same inequality will be there, but of course greater than or equals to. Right? So these two types of functions are called increasing functions. The simple definition is increasing function means with the increase of value of x, y value always increases. In that there are two types, strictly increasing function. That means it keeps on moving like this, keeps on like this, increase. That means that is strictly increasing function. It also non-decrease, keeps on increasing, but increases and then same value will be there and then increases. That type of function is called non-decreasing function. In non-decreasing function, one point you have to notice is some part of graph will be parallel to x-axis. Parallel to x-axis. That means in the example in C comma D, some part of the graph will be parallel to x-axis. Parallel to x-axis. Non-decreasing function means. Right? So this is increasing function. Suppose example you take. Example of increasing functions are y equal to e power x. Y equal to e power x. Its graph will be like this. Its graph will be like this. E power x we have seen. Its graph will be like this. So this is increasing function. Look at how minus infinity, its value will be close to 0. It keeps on increasing like this. Look at x value here it will be like this. At x value here it will be y value will be like this. At x value here y value will be like this. It keeps on increasing. Right? This is called increasing function. Suppose another function is there. Log x to the base e. Log x to the base e, if you take the graph, log x to the base e, how the graph will be like this. Like this. Right? It is also keeps on increasing like this. Look at, if you take x value here, y value will be here. If you take x value here, y value will be here. So whenever you take x1 less than x2, suppose here x1, here x2. So this is f of x1, this is f of x2. So it is also strictly increasing function. These both are called strictly increasing functions. Next. So from the graph, if you are able to draw the graph, in the interval, if it keeps on increasing like this, it is called increasing function. If some part of the graph parallel to x-axis, then also increasing function. From the graph it is, if you draw the graph, suppose next point, f of x is said to be increasing at a point x equal to a. At a point x equal to a, it is said to be increasing at a point x equal to a if for suppose neighborhood of a we will consider. neighborhood of A. H is very small. H is very small. Nice. If we apply the inequality, f of A minus H less than f of x less than f of A plus H. Right? So, if x equal to A, neighborhood we will take small interval from left to right. Then if it satisfies f of A minus H less than f of x less than f of A plus H, then f of x is said to be increasing. That means that is f of x increases in x belongs to A minus H, comma A plus H. Look at here. At a point, f of x is said to be increasing. Look at a point you have to check means, suppose at a point you are asked to check. You are asked to check at x equal to A, you take. Suppose x equal to A, graph is like this. X equal to A. Right? At x equal to A, graph is here. At x equal to A, it is said to be increasing. Look at, you consider a small interval from left to right, small neighborhood, right? At x equal to A, whether increasing or not, you have to check means you consider a small interval from left to right. So this is x equal to A minus H. This is x equal to A plus H. Right? So in A minus H to A plus H, if you observe the graph, like this it is there, like this it is there, right? So in this interval increasing or not, if in that interval, if the graph is increasing, then f of x is said to be increasing at that point. That means if you take this interval, A minus H less than x less than A plus H, what happens if you apply the inequality f of A minus H less than, same inequality will maintain, less than f of x less than f of A plus H means this is f of A minus H, this is f of A, this is f of A plus H. How those values are? This is f of A minus H, this is f of A, this is f of A plus H. That means if this inequality is satisfied, graph will be like this. Graph will be like this. Just simple. At a point he asked, then at that point you take some interval from left to right, very close, H is very close. If in that interval, if it is an increasing function, then it is said to be increasing at that point. Now f of A minus H means this one. F of A minus H is nothing but right hand limit, left hand limit, left hand limit. For calculating this one, what you need to calculate is limit this. F of x. That means left hand closest value is f of A minus H. Right side to A closest value is what? F of A plus H. This value less than uh, f of x less than f of A plus H. Here x is A. Here x is A. Okay. X is A you take. X is A. Right? At x equal to A means A minus H less than A plus H. Then if you apply the inequality, same inequality must be there. This is increasing. Next, we will come to the next part. F of x is said to be decreasing function. decreasing function. In domain D, if x1 less than x2, if and only if f of x1 greater than or equal to f of x2, greater than or equals to f of x2. Now, if it is decreasing function, if you apply f, then if less than means greater than or equal to will be there. Greater than or equal to will be there. Such type of functions, graph will be like this. Suppose a graph is there like this. A graph is there like this. In A to B is the domain. A to B is the domain. Suppose if you take x1 less than x2, that means this is x1, this is x2, this is x2. That means f of x1 is what? This is the one, f of x1. F of x2 is where? Here. Look at. So x1 is this x. Lesser value of x will have more y value. Look at. Y value is this. Now x is increased to x2. At x2 it has lesser value. That means, look at here. Here its value is this. Next, if x increases, y value decreases from here to here. If x increases, y value decreases from here to here. That means with the increase of x, y value decreases. That means, look at what is this definition is. With increase, INC means increase of x. With increase of x, y value decreases. Y value decreases. If with increase of x, y value decreases, that is called decreasing function. So this is first one, first type. Suppose second type, look at second type. Look at, if the graph is like this. Suppose graph is like this. Domain is A to B. A to B it is defined. Look at between C to D, same value is there. That means graph parallel to x-axis. Look at from A to B, if you see, suppose x1 you take here x1, x2 you take here x2, x2, anyway, your choice. Now look at f of x1 is this, f of x2 is this. So f of x1 greater than f of x2. So next, suppose if you take x1 here and x2 here, f of x1, f of x2 both are equal here. So both will have equal, right? So this value. Here if you take f of x1 equal to f of x2, suppose if you take x1 here, x2 here, then f of x1 will be here, f of x2 will be here. This is f of x1 greater than f of x2. That means for this type of second graph, x1 less than x2 implies f of x1 greater than or equal to f of x2. Here in this interval, if you take x1 and x2, then you will get f of x1 equal to f of x2. Look at what is this is, it keeps on decreasing. It keeps on decreasing like this. For some values of x, it will get the same value and then again decreases. It will never increase. Keeps on decreasing but maintains same values in some interval and then again decrease. Here, this type of graph, it keeps on decreasing only. It will not get same value at 2 points. Difference between this and this, only this part. Only this part. This part is parallel to x-axis. So, it is also categorized into two types. Decreasing functions are of two types. Decreasing functions are of two types. Number one, strictly decreasing function. Strictly decreasing function. X1 less than x2 if and only if f of x1 greater than f of x2. That means if inequality is there like this, so less than will become greater than if you apply f. If it is strictly increasing, if greater than is there here, then it will become less than. Then it will become less than. Such type of function is called strictly increasing function. X2 belongs to domain. Belongs to domain. Right? This is called strictly decreasing. This one, first part. First graph. Second one is non-increasing function. Non-increasing function. F of x1 greater than or equal to f of x2. That means just equal to will come also. So suppose if greater than is there here, then less than or equal to will be there here. For all x1, x2 belongs to the second graph, second type of function. These both are called decreasing functions only, but has particular name. This is called strictly decreasing function. It is called non-increasing function. It will never increase. It keeps on decreasing same value and then keeps on decreasing, but will never increase this one. This is also called decreasing function and particular name non-increasing function. For this type of function, some part of graph is parallel to x-axis. Some part of graph will be parallel to x-axis. In the second graph, C to D will be parallel to x-axis. So this is from the graph. Suppose example if you take examples of decreasing functions. F of x equals to e power minus x. E power minus x. That graph will be like this. That graph will be like this. This. Right? Decreasing means from top to below you will get. Increasing means from bottom to top you will get graph. Always remember. Decreasing means from top to bottom. From the top it will be till bottom. Increasing means from the bottom to top. Like that graph will be there. So this graph if you see, look at minus infinity to infinity. At minus infinity it has maximum value above. Graph is above. At minus infinity its value is what? Above. Plus infinity. At plus infinity its value is what? 0. That means if x keeps on increasing, look at here y value is where here. Here y value is where here. If x keeps on increasing, y value will keep on decreasing. This is called strictly increasing function. SI. Strictly increasing function. Suppose another example. It is called strictly increasing function, or you can say increasing or decreasing function. Strictly decreasing function. You can say decreasing function also. Whenever you got strictly decreasing function, instead of this you can write decreasing also, no problem. Because if these both will come, that is, you can write decreasing even. The particular name is strictly decreasing. Even you can write decreasing also, no problem. Suppose another example. Y equal to log x to the base 1 by 2. Log x to the base 1 by 2. If base is less than 1, then the graph will be like this. If base is greater than 1, previous case, log x to the base e. If base is less than 1, its graph will be like this. Its graph will be like this from above to, look at, domain is 0 to infinity. At 0 here it is there. What is the plus infinity? So from here it keeps on downfall. Downfall means decreasing. It increases means increasing. Like that. This is strictly decreasing function, or otherwise we can say decreasing function. Look at next. F of x is said to be decreasing at a point. Decreasing at a point x equal to a. At a point x equal to a, if you consider a small interval from left to right, you consider like this. Right? You consider a small interval from left to right, neighborhood of a. So if this is for these values, if you apply, you will get f of a minus h greater than f of a greater than f of a plus h greater than f of a plus h. Like this, it will be there. That means, look at here. It is said to be decreasing at a point. It is said to be decreasing at a point. Suppose, look at it. Like this is there. At x equal to a, it is said to be decreasing. At x equal to a, it is said to be decreasing. It is said to be decreasing. You consider a small interval from left to right. Small interval from left to right. So this is a minus h. This is a minus h. This is a plus h. Right, in between middle is a. Look at f of here at a minus h. F of a minus h is this. So at a, this is f of a. At a plus h, it is what? F of a plus h. This inequality will be satisfied. That means simply f of x decreases in a minus h comma a plus h. That means from the graph you have to check, means you consider a small interval from left to right. In this graph you observe, in this interval it keeps on decreasing. This from top to bottom you got. That means what? In this interval, f of x is decreasing. Then at that point x equal to a, f of x is said to be decreasing. Decreasing. Whenever you are checking at x equal to, you consider a small interval. Small interval. In that small interval, if f of x decreases, then at that point it is said to be decreasing. So I have told this is left hand limit, this is right hand limit. Calculating that value. Now to next. Look at one problem. Look at one problem based on the basic. The number of integral values of lambda for which f of x equals to x plus 3 when x less than 3, lambda when x equal to 3, 3x square minus 3x minus 3 for x greater than 3 is increasing. Increasing means I will always write INC from now onwards. Increasing means INC, decreasing means DEC. Look at, he is telling that f of x is increasing at x equal to 3. Increasing at x equal to a. Now look at, always you write like this. 3 minus h less than 3. You consider a small interval like this. Right? F of 3 minus h less than f of 3 less than this one implies what I told. F you apply. Increasing means same inequality. If you are applying same inequality, like this. So now f of 3 minus h is limit extends to 3 minus left hand limit. Left hand limit means x plus 3. That means this is what 6. So this is what 6 f of 3 plus h, right hand limit 3 plus 3x square minus 3. 3 into 9, 27 minus 9 minus 3. 27 minus 12 is 15. This, so this is f of 3 plus h. So lambda, f of 3 is given, what? F of 3 is given lambda. Huh? What is? ఏంటమ్మా doubt? ఏంటమ్మా? చెప్పమ్మా. ఇదే? ఆ, ఏంట్రా డౌట్? ఇంక్రీజింగ్ కదా నేను ఇచ్చింది. ఏ ఇంక్రీజింగ్ కదా ఇచ్చింది, ఇంక్రీజింగ్ కదా. సేమ్ ఇన్ఈక్వాలిటీ ఉంటుంది. ఇంక్రీజింగ్ అంటే డిక్రీజింగ్ అది పైన. ఇంక్రీజింగ్ అంత ముందు చెప్పాను కదా అది. సో దేర్ ఫోర్ లుక్. సో హియర్ యూ సబ్స్టిట్యూట్ మ్యూట్ అవుట్ 6 less than lambda less than 15. So lambda, what he is telling in number of integer values of lambda. What are the integers here? 7, 8, 9, 10, 11, 12, 13, 14. So answer 1, 2, 3, 4, 5, 6, 7, 8. 8 values. Like that, increasing means at x equal to, you consider this small interval 3 minus 6 less than 3 less than 3 plus h. Then you write this one, f of 3 minus 6 less than f of 3. Same inequality will be maintained. If you apply f of that, if it is increasing, same inequality. F of 3 minus 6 you calculate left hand limit. F of 3 plus 6 you calculate right hand limit, and then use this one. So this is 6. And this is f of 3 given lambda, and this is 15. So lambda must lie between 6 and 15. What are the integer values? These are. Next, look at if look at if f dash a greater than 0 at x equal to a. Look at here. If f dash a greater than 0 at x equal to a, then derivative method to check. Look at, then f of x is said to be increasing at x equal to a. Look at derivative test is, suppose you have to check whether at x equal to a increasing or decreasing. Suppose find the derivative at that point. If the derivative is positive at that point, then it increases at x equal to a. Look at f dash a greater than 0 means implies right hand derivative greater than 0 left hand derivative greater than 0. For derivative, there will be two parts. Right hand derivative will be there, left hand derivative will be there. Right? So, right hand derivative greater than 0, left hand derivative greater than 0. Right hand derivative definition is what? Limit h tends to 0. F of a plus h minus f of a divided by h greater than 0, comma. What is the definition of left hand derivative we have learned? F of a minus h minus f of a divided by minus h. These both must be greater than 0. These both must be greater than 0. Then what you will get here? So look at this, h is positive. This h is already denominator positive. H is always positive. This ratio has to be positive, means f of a plus h minus f of a positive, comma. Here in the denominator negative quantity is there. This ratio must be positive. That means numerator must be negative. That means what you are getting here, f of a plus h greater than f of a, comma, f of a minus h less than f of a. Look at this, you can write it as f of a less than f of a plus h. From this side you write. So these both if you club, what you will get? Less than f of a less than f of a plus h. Less than f of a plus h. This concludes that f increases at x equal to a. F increases at x equal to a. Look at here. What this suggests is at x equal to a, its value is this. F of a minus h. At a minus h, its value will be what? Less than f of a. Here it will be. Then at x equal to a plus h, how it will be? It will be more than f of a plus h. That means at x equal to a, from left to right, graph will be what? Increasing. This. That means for a function, if derivative exists, that means at x equal to a, it must be differentiable. Then only you can use the derivative test. At x equal to a, if derivative is positive, then f of x is said to be increasing at x equal to a. Increasing at x equal to a. Similarly, we can say, if f dash a less than 0 at x equal to a, then f of x is said to be decreasing at x equal to a. Decreasing at x equal to a. That means at any point, if the derivative is negative, decreasing. If the derivative is positive, increasing. This is called derivative test. In both cases,